everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over our special products and specifically our square of a binomial. So it's important when we're doing this that we're not expanding it, we're not foiling it, we're getting our polynomials using a specific rule so we can do this in a quicker fashion. The whole point of this is to understand the reasoning behind what we're doing, but to do it in a quicker fashion so we can get through these problems correctly in an efficient manner. So to do this, we have to know what a square of a binomial is. So a square of a binomial will look something like a plus b to the second power. So we're taking a binomial and we're squaring it. When that occurs, we have the rule where we take our first term, we square it, plus 2 times our first times our second, plus our second square. And all of that sounds crazy. All of that sounds like a lot. But once you put it into motion, it's not as crazy as it seems. The same thing applies when we have a minus b, but instead we're going to throw that minus sign in front of the 2. So the minus accounts for the negative 2 here. We won't make this a negative b. Our answer is still b, but once we use the minus here, there's no more negative. So let's take a look at some problems so we can see how we would accomplish this. So we have problem number 1 here. And if I look at it, I have a binomial that's being raised to the second power. I'm squaring it. So I can use my formula of a squared plus 2ab plus b squared. To start off, I'm going to expand it for you so you can see. But as you become more professional and more understanding of this material, you won't have to expand it. You'll just think, I square this, I do that, and continue with the formula. So what I'm going to do is I'm going to do a squared plus 2ab plus b squared. Here, my a is my first term, which is 3x. So I am squaring 3x plus 2. My a is 3x once again. My b is 4. And then once again, my b is 4. You can put the 4 in parentheses, or you don't have to because it's not doesn't have a variable attached to it, but either way, that's how we would expand it. Now I'm going to square it. And what I think about is I'm using my power rule here. My power rule tells me to raise the coefficient to the exponent, then multiply my exponents. So if I raise it, I'm raising 3 to the second power, which is 9. And then my exponent of my 1, I raised it. Now I'm multiplying 1 times 2, which is 9x squared. Then I have to think about this. I am not distributing my 2 to each of my a and b terms. I am multiplying all of these together. So 2 times 3 times 4, which is 24. And I have an x, so I'm going to leave it as an x. Then I have my 4 squared. So 4 squared is 16. And that is my answer. So we're going to do that instead of expanding it and foiling it because it's a quicker process and much easier to use when we move on to our more intense math classes where we have to boom, boom, know it and move on. Let's take a look at another problem. So now we have this problem where we have another binomial being raised to the second power. So we're squaring a binomial. And if we look, there's a minus in between the 2 terms. So we're going to use our formula that has the minus 2ab. So I'm going to have a squared minus 2ab plus b squared. I'm going to square the first term. That's my a term. However, I'm not going to show you this expanded because we want to get used to working on this without having to write down the formula every time. It defeats the purpose. So if I square the first term, 5 squared is 25. Then I raise x to the second power, which is x squared. I'm minus 2 times 5 times 2, which is 20. I have an x and a y, which just stays as xy. Then I raise the 2y to the second power. So 2 to the second power is 4, y to the second power. And that would be my final answer. So without having to write out that formula, which of course we're just beginning, you can do that. But I have to think, I'm squaring the first term, minus 2 times this, plus my b term squared. Let's try one more problem where we're really stepping it up. So now we have this problem, which is a little bit more intense, but I know we're able to handle it. So if I have something like this, I have a binomial being raised to the second power, I'm squaring it. I am going to use my formula of a squared. Look, this is a plus, so I'm going to use a plus 2ab plus b squared. So I square this term. I'm raising 4 to the second power, which is 16. I have x to the second. I'm raising it, so I multiply 2 times 2, which is 4. I have y, which is to the first power. I do 1 times 2 because I'm raising it to the second power, which is 2. So what I did was 4x squared y to the second power. I raised the 4, then I multiply 2 times 2, 2 times 1. Now I have the plus. I do plus. I'm doing 2 times 4 times 3. Well, 2 times 4 is 8, times 3 is 24. This is where I'm using my product rule where I multiply my coefficients and add my exponents. So we always start off with the power rule. Then we are going to use our product rule. So that means I add my exponents. I have 2 and 1, which is x to the third. I have 1 and 2, which is y to the third. Then once again, it ended off with squaring it, which means I'm using my power rule again. So it's power rule, product rule, power rule. So I do 3 to the second power, which is 9. X to the first, to that second power. We're multiplying. I raised, now I multiply. 1 times 2, which is 2. Then I have y, 2 times 2, which is 4. None of these can be combined, which they shouldn't be able to, and that would be my final answer. So I hope that these detailed problems were helpful to understand how we would use special products when we're talking about squares of binomials.